All right, so today we're going to look at exponential growth. I thought this was funny. This cat's always shooting for exponential growth. So the what, why, and how. We will learn how to write an exponential function that models a scenario. Why do we learn the what? To help students make predictions regarding growth models. And how do we know we've accomplished the what? Students will be able to use the function f of x equals, there's our generic formula for today, to represent various growth models. Okay, so it's a little bit different if you look at it, a little bit different. Okay, exponential growth will occur when the b value is greater than 1. Okay, we already knew that. That was something we learned from 6-2. Okay, so, but our b value is going to, the way we approach it, getting the b value is going to be a little bit different today. Okay, so looking here, is this exponential growth? Okay, I'm going to say no, because this 1/2 is less than 1. Okay, what about here? Exponential growth? I'm going to say yes, because my b value is greater than 1. It's 3. Okay, what about this one? H of x? I'll look at the b value. That b value is less than 1. So 1.45, now we have a decimal. Still bigger than 1. So yeah, that's exponential growth. And then 1.02, again greater than 1. Okay, it doesn't matter about this big number out here. That doesn't matter. Okay, what we look at is the b value. Okay, remember this is just our initial value. This is where it's going to cross the y-axis. That's going to be the y-intercept. So that's less than 1, so that one is not exponential growth. That would be decay. Okay, so this is the formula we're going to use. This is it right here. So if you're going to write anything down, this would be what you write down. Okay, so it's different now because we got this 1 plus r. But once we add them together, that will give us our b value. That will determine if it's growth or decay. But since it's 1 plus r, it's going to be growth. Okay, again, a is our initial amount. And then this 1 plus r, this is our growth factor. This is how much we're growing by. Okay, so we're talking about population, we're talking about cost, a lot of different things in order to represent this growth model. Okay, so before we can get started, we need to know how to convert a percent into a decimal. So it looks like some of my animation was off here. But, so this is 45%. So pretend that decimal wasn't there yet. And it says to move the decimal to the left twice. Okay, so what we'll do is we'll take this decimal and we'll move it over twice. And we end up with 0.45. So as a decimal, 45% is 0.45. All right, let's say we're looking at 3.2%. Again, we move it over twice, so we bring it over. Now it's in front of the 3. Move it over again. Now there has to be a 0 there as a placeholder. So that would be 0.032. Okay, what if we wanted 5%? We want to put it as a decimal. We want to convert it into a decimal. So there's a hidden decimal right here. It's 5. So we bring it over twice, and we need a placeholder right here. There'll be a 0 in front, and that would be 0.05. Or let's say we want 2.5%. So let's bring the decimal over twice, and we end up with 0.025. Okay, and then let's say we have 60%. So again, the decimal's over here. Bring it over twice. And we end up with 0.6, or you can even put 0.60. It doesn't matter. But you don't need that extra zero at the end. So 0.6. Okay, so why don't you try these? So we've got 2%. Convert it into a decimal. It's going to be 0.02 because we're moving it over 2 times. 73%. The decimal's right here. So it's going to be moved over twice, 1, 2, and it becomes 0.73. Okay, so we're going to use it in today's lesson, use that method of converting a percent into a decimal. Okay, so here's an example. So it says in 2016, Buena Park had a population of 82,863. If Buena Park's population grows at an annual rate of 20%, what will be the estimated population of Buena Park in 5 years? Okay, so we know that it's growth because it says the population grows. So we're going to use this growth model with this 1 plus r. Right there, this 1 plus r. So initial value, growth factor, and then this will be the years here. So a times 1 plus r to the x. So let's identify, we need to know the a and we need to know the r. Okay, the a is the initial value. Well, right now we're talking about in 2016. So the initial value is this 82,863. And the r value is the rate, the annual rate, so 20%. But we need to put it into a decimal so we can combine it with our numbers like 1. So we move it over twice, and it ends up becoming 0.20 or 0.2. Okay, so we can plug those values in. Okay, we combine 1 plus 0.2 is 1.2. And we want to know in 5 years. Okay, again, that's our growth factor, so 1.2. All right, we have to put the 1 in front because if we just left it as 0.2, it'll be decay. Okay, so it's itself plus that 20%. That's really what's going on here. Okay, so we want to know in 5 years. So what we'll do is just put the 5 as an exponent here. Okay, and I don't expect you guys to do this in your head. There's no way. So what can we use? What can we use to help us? Okay, calculator, my favorite, Desmos. Slap it into Desmos. And you can just put it in the way it is, just like this. And this is what it gives us. So 206,189.66. Okay, so let's write a conclusion about this. So this is what we got. Now we can't say that there's 0.66 people. We can't say that. Okay, so we'll have to round here, and I think on mine I rounded wrong because I just dropped the 0.66. Okay, but that's how I would do it. I would just say 206,189 and just drop the decimals because you can't include those. But looking in the book, they actually rounded from the 1 spot, so that would actually bring it up. So it'd have to be 190. So let me change that. Okay, so from 206,189.66 to 206,190 in 5 years. So notice how I wrote a sentence. Okay, starts with the word problem, starts with words, ends in words. Okay, let's look at example 2. So here we're talking about college students. Okay, at a college is 16,000, grows 6% each year. How many will be enrolled after 26 years? Okay, so we see the word grows, so we know it's exponential growth. So there's our function, our generic function right here. Okay, we need to find our growth factor. And that should be easy. You should already know it in your head what it should be just by looking at that 6%. So our A and R values, so A is 16,000 because that's our initial. So right now there's 16,000 students. Our rate, it grows 6% each year. So we got to move the decimal over twice. So there's going to be a 0 there as a placeholder. So 0.06. So we've got our A is 16,000. 1 plus 0.06 is 1.06. So our growth factor is 1.06. Okay, and we want to know how many will be enrolled after 26 years. So let's plug in 26. Okay, and let Desmos do its thing. So we can plug this into Desmos. Go ahead and do that. Okay, round to the hundredths, which is 2 decimal places. And then we'll round to the ones when we write our conclusion. Okay, so this is what we get. So 72,790.13, because the 7 is bigger than, it's 5 or bigger, so this becomes a 3. And then if we round it to the ones position, we look over here, and it's going to stay at 0. So there'll be 72,790 approximately students enrolled at this particular college in 26 years. Okay, so we do write a conclusion. Okay, so let's look at another example. Second, fix this. And we're going to begin from the left. Okay, so go ahead and do that one. Plug in your answer. Okay, so we're going to use this sign. Don't forget to use this sign for our initial amount right here. This is the initial amount. Okay, so we know it's a growth model. So A is 5,000, and it's a rate at 15%. So that's going to be 0.15. Let's plug them in. Got our A, we got our R. So that's 1.15. We want to know in 5 years. So let's plug in the 5 here for X. And let's let Desmos do its thing. Okay, we'll round right here. So it should be 0.79. And then write our conclusion. So Hillville will have a population of round of the ones, so that's going to go up to 7 of 10,057 in 5 years. Okay, several different ways you can write a conclusion right there. Okay, hopefully you guys did good. If you have questions, you guys can ask me. Thank you.